Welcome dear students to this session. Dear students, today we are going to discuss from class 9 mathematics book chapter 8 Quadrilaterals part 4. Dear students, previously we have discussed about the properties of parallelogram. So what properties we have discussed, let's see. A diagonal of a parallelogram divides it into two congruent triangles. And another property is, in a parallelogram, opposite sides are equal. And converse of this says that if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. And another property says, in a parallelogram, opposite angles are equal. And its converse says that if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. Today we are going to discuss some more properties about parallelogram. What are they? The statement is like this: the diagonals of a parallelogram bisect each other. To prove this, let's have a figure. This is figure of a parallelogram. ABCD is a parallelogram. AC and BD are the diagonals, intersect each other at O. Now, what to prove? Here we have to prove that the diagonals of the parallelogram bisect each other. That means AO is equal to CO and BO is equal to DO. Then how to prove this? In this figure, AB and CD are parallel, as this is a parallelogram, opposite sides are parallel, and AC is a transversal. If we consider these three sets of lines, then we have these angles, that is angle BAC and angle ACD, to be alternate interior angles. And you know, in parallel lines, what is the relationship between the alternate interior angles? So we can write that angle BAC is equal to angle ACD. And we can also consider another set of lines, like AB is parallel to DC and BD is the transversal. If BD is the transversal, then what are the alternate interior angles? ABD and BDC are the alternate interior angles. So we can write angle ABD is equal to angle BDC. Now, in triangle ABO and CDO, we have these two triangles to be compared for congruency. So in these two triangles, what are equal? Angle BAO is equal to angle DCO, because these two are alternate interior angles, and angle ABO is equal to angle CDO. These two are also alternate interior angles. And we have another condition, that AB is equal to CD, as they are the opposite sides of a parallelogram. Now, by angle side angle property, these two triangles are congruent. So we can write triangle ABO is congruent to triangle CDO. We can have the corresponding parts of these two congruent triangles. These are AO is equal to CO. From AOB, AO, and its corresponding side of CDO is OC. So AO equal to OC. Similarly, if we take BO, then its corresponding side in DCO is OD. So BO equal to DO. So we proved this. These are the corresponding parts of congruent triangles. Now we proved that in a quadrilateral, if it is a parallelogram, then its diagonals bisect each other. Now, what is the converse of this theorem? the converse of this theorem says that if the diagonals of a quadrilateral bisect each other, then what is the type of quadrilateral it is? It says if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Now, to prove this, have figure here ABCD is a quadrilateral, and in this quadrilateral we have given that AC is a diagonal and BD is another diagonal, and these two diagonals bisect each other at O. Bisect each other means AO is equal to CO and BO is equal to DO. Then what to prove? We have to prove that ABCD is a parallelogram. So, how to prove this? To prove this, let's see, in triangle ABO and triangle CDO, we have these two triangles for comparison. In these two triangles, we have AO is equal to CO and BO is equal to DO. Also, we have angle AOB is equal to angle COD. Why these two angles are equal? Because they are vertically opposite angles. So, we have side, angle, side. So, ABO triangle and CDO triangle are congruent by side angle side congruency or SAS congruency. Now, as these two are congruent, so we have some corresponding parts to be equal. So, in this case, we have AB is equal to CD. Again, if we take these two triangles, triangle ADO and triangle BCO, then what are equal? We have AO equal to CO and BO is equal to DO. And also AD and BC are equal as the opposite sides of a parallelogram. Now you see, as triangle AOB and COD are congruent, we can say that AB is equal to CD as the corresponding part of the congruent triangles. Now, we consider triangle AOD and triangle BOC. You see, in this case, as given, AO is equal to CO and DO is equal to BO. Also, we have angle AOD is equal to angle BOC as they are vertically opposite angles. So, we have triangle ADO and triangle BCO to be congruent. So, we can write triangle ADO is congruent to triangle CBO by side angle side congruency or SAS congruency. As these are congruent, so we can say that side AD is equal to side BC. Why? Because these two are corresponding part of the congruent triangles. Here we have ABCD is a quadrilateral and its opposite sides are equal. AB is equal to CD and AD is equal to BC. And we know that in a quadrilateral, if in a quadrilateral the opposite sides are equal, then it is a parallelogram. From this we can conclude that ABCD is a parallelogram. Dear students, today we discussed about the diagonal property of the parallelograms. Let's have some questions, some more properties of some special parallelograms. Have a look. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So, how to do this? This is a parallelogram ABCD. So, given ABCD is a parallelogram, and ACBD are diagonals such that AC is equal to BD. Then what to show? We have to prove that ABCD is a rectangle. Then what is the condition for a parallelogram to be rectangle? If one angle of a parallelogram is 90 degree, then that will be a rectangle. So let's see. If we compare two triangles here, that is in triangle ADC and triangle BDC. ADC and BDC, what are equal? You see, AD is equal to BC. Why? Opposite sides of a parallelogram. Now, it is given AC and BD are equal. AC and BD are equal, it is given. And DC is equal to CD is common side. This DC or CD is common side. So, we can say triangle ADC is congruent to triangle BCD by side congruency. Okay? Now, if these are congruent, then we can have equal parts, like as we need angle ADC is equal to angle BCD by, let me write in short, that is corresponding parts of congruent triangles. Now we know that AD parallel to BC, as ABCD is a parallelogram, and CD is transversal so angle ADC plus angle BCD is equal to 180 degree as their co-interior angles. Sum of the co-interior angles is 180 degree. So angle ADC plus angle BCD is equal to 180 degree. And we know ADC and BCD are equal. So this shows that each angle is 90 degree. That is angle ADC is equal to angle BCD is equal to 90 degree. As both are equal and their sum is 180 degree, so each is half of it. So ADC is equal to BCD is equal to 90 degree. As one of the angle is 90 degree of a parallelogram, then it is a rectangle. So we can write as ABCD is a parallelogram and one of its angle is right angle, then ABCD is a rectangle. This is all we have to prove. So we proved from this properties of parallelogram that if the diagonals of a parallelogram are equal, then it is a rectangle. Now let's have a look at another property. This says that show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. Here, given that a quadrilateral is there and the diagonals bisect each other perpendicularly. So, name the quadrilateral ABCD and the diagonals bisect each other perpendicularly at O. So, given in quadrilateral ABCD, diagonals AC and BD bisect each other at O and AC is perpendicular to BD. We have to prove that ABCD is a rhombus. Okay. In this case, you see how to prove. It is given that the diagonals bisect each other. So, as AC and BD diagonals of quadrilateral bisect each other, this implies ABCD is a parallelogram. ABCD is a parallelogram. This means AB is equal to CD and AD is equal to BC. Now, let's take two adjacent triangles as formed by the diagonals. So, let's take in triangle AOB and triangle BOC. What are equal? As it is bisected, AC is bisected at O. So, AO is equal to OC and OB is equal to OB is common side. What's more, and it is given that AC is perpendicular to BD, that means the angle BOA is equal to angle BOC is equal to 90 degree. So, from this we can say that triangle AOB is congruent to triangle COB, and by side angle side congruency. This implies by taking the corresponding parts of congruent triangles are equal, we can say that AB is equal to BC. Now we had AB equal to CD, AD equal to BC, now AB equal to BC. Now from these three we conclude that AB is equal to BC and BC equal to AD, and AB is equal to CD. So as all the four sides of a quadrilateral are equal, so ABCD is a rhombus. So thus, by applying the properties of parallelogram, we can prove that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. Let's have another question. The question is like this: show that the diagonals of a square are equal and bisect each other at right angles. In this question, a square is given. So let's draw a square. ABCD is a square. What to prove? We have to prove that the diagonals are equal and bisect each other at right angles. So, to prove AC and BD diagonals, AC and BD diagonals are equal. That means we can write simply AC is equal to BD, and also the second part says that AC and BD bisect each other at O and AC is perpendicular to BD. Now you see, as we discussed earlier, that a square is both a rectangle and a rhombus. So it has both the properties of rectangle and rhombus. So we can use that. ABCD is a square. This implies ABCD is a rectangle. As we know that every square is a rectangle, so we can write ABCD is a rectangle. As ABCD is a rectangle, we also know that in a rectangle the diagonals are equal. So the diagonals of ABCD are equal, that is AC is equal to BD. What is the second property of square? Square is also a rhombus. So we can write that ABCD is a rhombus. As ABCD is a rhombus, and we know the diagonals of a rhombus bisect each other perpendicularly, so we can simply write that the diagonals of ABCD bisect each other perpendicularly. So by using the properties of square, that it is both a rectangle and a rhombus, by using the properties of rectangle and rhombus, we can prove this statement that the diagonals of a square are equal and bisect each other at right angles. Now let's have another question. The question is like this: show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. This statement is nothing but the converse of the previous statement. So let's prove it. In this case, the quadrilateral is given and its the properties of diagonals are they bisect each other at right angle. So here it is given in quadrilateral ABCD diagonals AC is equal to BD and both the diagonals bisect each other perpendicularly What to prove? We have to prove that ABCD is a square. Just as we discussed, the square has both the properties of a rectangle and a rhombus. If we can show that this ABCD is a rectangle and a rhombus, then it is a square. So from the first condition, let's start. In ABCD quadrilateral, diagonals AC is equal to BD, and we know that if the diagonals of a quadrilateral are equal, then that is the diagonals of a parallelogram are equal, then it is a rectangle. So here this is a rectangle. Let's first prove. Let's prove that the diagonals of ABCD bisect each other. This implies ABCD is a parallelogram. Now, the diagonals AC is equal to BD. This implies ABCD is a rectangle. Now, the diagonals bisect each other perpendicularly This implies ABCD is a rhombus. Thus, ABCD is a square. So, thus by using the diagonal properties of rhombus and rectangle, we can prove this, that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. Dear students, today we discussed the properties of parallelogram, like the diagonals of a parallelogram bisect each other, and if the diagonals of a quadrilateral bisect each other, then that is a parallelogram. We also discussed different properties of square, rectangle and rhombus. Dear students, now this is time now to stop. Hope you have understood it. Thank you.